fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Yes, if you read the title of this episode, you'll know that this is yet again going to be me ranting about Ansible and why it's so amazing. But in addition to why it's so amazing, I'm also going to be talking a little bit about what I'm calling the Ansible way. Because there's a few ways that you can use Ansible, which we'll get into. The one is you do it the Ansible way, and the other one is you basically use Ansible as a glorified way to run a collection of shell commands. So we're going to dive into that in this episode, but first, let's get into this week's trivia question. The IEEE is well known for standardizing things. For instance, the IEEE 802.3 is a collection of standards produced to define the physical layer and data link layer of wired Ethernet. But what does IEEE actually stand for? So what does IEEE stand for? And that is your trivia question for the week. Now, a few episodes ago, maybe like a couple months ago, we talked, about burnout with developers and, why some companies don't treat developers necessarily as good as they should and why developers are leaving so frequently compared to other professions. And one potential contributing factor could be the fact that these companies make their developers eat dog food. Now, that actually isn't completely true. Of course, these companies aren't making their developers actually eat real dog food, of course. And if there is any company out there that's actually doing that, I have some serious questions. But no, in this case, when we're talking about developers eating dog food, the practice actually refers to this saying in the software development world called eating your own dog food, which is essentially working off the latest beta. So, according to Wikipedia, the practice of eating your own dog food is, quote, the practice of using one's own products or services. So, essentially, you're basically beta testing your own software to make sure it's good for the masses. Because if the masses have to deal with it, well, you should deal with it as well. But the reason why it kind of has this stigma of not being good is because if you're always beta testing your latest software, anyone that has written software knows, especially in the early days of production, the software is anything but stable, and having to deal with constant crashes or random bugs is a great way to draw those bugs out and get them fixed before it actually gets deployed to the public. So you might have heard of the different stages of releases when it comes to software. You've of course heard of your release versions. There's a good chance you've probably heard of beta versions, which generally aren't necessarily the best, but generally fairly stable for the most part. And then even less common is the alpha releases, which is like even before beta, so things are still kind of changing. It's not exactly super stable, but when we're talking about eating your own dog food, we're talking like way before the alpha stage, right? So if you've ever, worked on any kind of program and there's just bugs everywhere, it's not stable at all, the slightest bit of ill-defined user input, or if the input isn't exactly what the function's expecting, it's just going to hard crash. Yeah, these are the kinds of issues that you're potentially going to be running into when you're, quote, eating your own dog food. But generally speaking, I would say the term of eating your own dog food mainly comes if you're actively using the tool as a development means. And what I mean by that is if you're writing, say, a word processor, right? You're not necessarily going to be editing the code in the word processor, right? You're not going to be using the word processor to build your code. Now, maybe you might be using the word processor to, write up some documentation perhaps, and then that could help you find bugs to potentially fix. So in that case, you'd be eating your own dog food. But I think historically speaking, the idea of eating your own dog food comes back to like operating systems development, right? So for instance, if you're building your own OS, the idea of eating your own dog food would essentially be using the latest development build of your operating system to then write the code for your operating system. So you're really getting into the weeds, dealing with all the bugs, and essentially patching them on the fly, and then recompiling everything, reinstalling the OS, and then starting again. And you can imagine the amount of instability that comes with all of that. But either way, if you are eating your own dog food, as it were, it's a great way to beta test the product, at least on yourself, because of course you're not going to catch all the bugs, because I don't know if anyone can ever catch all the bugs, but you'll at least catch the most obvious of bugs, because one other issue with developers is when we notice a bug or we know how a function should execute, we tend to write our test cases to fulfill those needs that we know. But the problem is we know how the software works behind the scenes. The end user does not know how the software works behind the scenes, which is why you can usually run into some interesting bugs once it actually gets released to the public, which is kind of where your alpha and your beta stages come into play. Because when you get to the point of, say, an alpha release, of course, it's expected that there are going to be issues and there's going to be bugs. But generally speaking, you should at least have the big noticeable ones kind of ironed out, right? Like if you're, for instance, taking in a string of characters, you should and you print that data back to the user. You shouldn't be printing out the hex representation of those characters. You'd probably want to actually print back what the user entered, unless the point of your program is to print the hex representation of the characters, in which case you're doing your job. So it's kind of things like that where it generally should be functioning as it should, but again, there's going to be, bugs here and there, especially in the edge cases that you might not have accounted for, or in your very narrow testing maybe didn't consider. But that is essentially the point of eating your own dog food. It's basically dealing with the mess that you made, essentially. And in doing so, you can improve it and find all the bugs, and, well, not all of them, of course, but, find the bugs, patch them, and all that good stuff. And with that, let's move into this week's cybersecurity tip. Now, this week's cybersecurity tip, again, shouldn't be a shock to people, but you would be surprised how many people don't follow this tip, if you will, and that is not to delay your patching. And the reason why I bring this up again is, like with some of our other cybersecurity tips, it's because of some news that has happened in the past week. So within the past week, both Microsoft and Google have been quite active in patching some security vulnerabilities. So on Tuesday, I guess, on their when they usually do their, I think it's Tuesdays when they do their security patches, they patched 61 security vulnerabilities along with 2 actively exploited zero-day vulnerabilities. So quite a number of issues there. And of course, if you're not keeping up with your patches, you would be susceptible to said vulnerabilities. But also, I mentioned Google. Google also was back at it this week, patching some other actively exploited 0 days in the Chrome browser. So these are just a couple instances where if you're not up on your patches, on the latest security fixes, you are potentially vulnerable to these flaws and exploits, and in these cases right here, 0 day vulnerabilities. And the reason, as we've touched on in the past, why 0 days are so bad is the name 0 day comes from the fact that the company didn't know that they existed and it was being exploited potentially. And in these cases, they were actively exploited, which means that there were attackers exploiting this vulnerability before Google and Microsoft even knew that these vulnerabilities actually existed. So that is definitely something that you want to be mindful of, because the other thing with 0 days is there is no patch for 0 day vulnerabilities. So if you aren't up on your latest patches, you could potentially be susceptible to 0 day vulnerabilities, which is basically just asking to get attacked, especially in some of these 0 day vulnerabilities that rank really high on their scores, on their CVSS scores, which is essentially determining how serious the vulnerability is. In the case of the Microsoft ones, one scored an 8.8 and the other scored a 7.8. So not quite the perfect 10s that we saw some other vulnerabilities earlier this year, like the XZ vulnerability. But still, nonetheless, some pretty high severity vulnerabilities that you definitely want to make sure that you're patching. And the thing that's always interesting is the percent adoption of some of these patches. Like, for instance, when there will be a patch that's released, it'll be interesting to see just how many installs there are out there, potentially in enterprise environments, that aren't running the latest patches and are susceptible to some pretty significant vulnerabilities. So you definitely want to be up on your patches, because while it might not necessarily be convenient at the time to, install these updates, the minor inconvenience of updating could potentially save you a lot of not only headache, but potentially cost in having to recover from a potential cyber attack or even ransomware attack. So let this be a lesson that you should definitely be keeping up with your patches. And if you're not, you probably want to start doing that. So that is your cybersecurity tip for the week. And before we get into the nerdy things, I think that we should let it be stated for the record here that I am not crazy and being unrealistic when I mention the fact that I need a bigger server rack in my house, because I had some company come over this past weekend and I was asked to show off my data center, and I was told by the people that asked to see my data center that I do indeed need a bigger rack. So of course I agreed with this sentiment, because I also think that I need a bigger one, but it just goes to show that someone besides me also thinks that I need a bigger rack. And the crazy thing about this is, when I first started my lab, I technically, I guess, started my lab, I think it was probably back in like 2018, before I even knew what home labbing was. But when I first actually got my rack, I started out with a 15U rack, and the funny thing is, when I first got it, it was completely barren and empty. I think I had like a small switch, a patch panel. I'm trying to remember when I first got it if I had so at one point I built my own custom 2U server, and I can't remember if that was right when I got the rack or a little bit after. But regardless, it was that and then a small shelf for my OG Dell Optiplex 7010. And when I first got, the rack and everything, I would look at it and see how empty it was and think, man, how am I gonna, how am I ever gonna fill all this? And then, of course, whatever it ended up being 3-4 years later, however long it's been, now, if I want to add something to the rack, I have to do all kinds of gymnastics and Tetris puzzles just to try to get things to fit and actually, slot into the rack, whether that's trying to rearrange servers around or trying to make room on a rack shelf, or it's a struggle. The 15U is very much filled at this point. So at some point there probably will need to be another rack, but I guess on the bright side, my wallet is probably happy because if I don't have any rack space to put servers, it kind of limits my ability to buy more servers because I don't really have any place to put said servers. But let's be honest here, that's probably not going to stop me because it wasn't all that long ago where I did have some empty space in my rack, and then shortly thereafter, a random R730 just magically appeared. Don't tell my wallet. But, things like that, if there is empty space, the space will be filled, is basically what I'm trying to say here. So potentially it could be a good thing, but also at the same time, it is nice to get and play with more hardware, even if that hardware isn't actually powered on. Because if we're being honest here, I would say close to, well, maybe not quite half, but like a decent percentage of the rack space that's occupied right now is actually unused, and some of it's even not even plugged in. Notably the Xserves, the Xserve and the Xserve RAID. They basically just sit there looking pretty because of course they are, but they're also massive power hogs. So yeah, but they are nice to look at. But even still, just having like servers in there just to play around with, whenever you feel like it is also quite nice. But anyway, with that, let's get into what nerdy stuff have I been up to this week. So I found another bug in my Server Connect program, which this kind of, happens from time to time when I'm playing around with some features or whatever that I haven't touched in a while. And this is, I think, kind of a remnant of when I completely re-architected the program. So when I first created the Server Connect program, it was just one large Python script. And then it eventually got to the point where I think it was close to like 1,000 lines of Python code. And I was like, okay, this is kind of too crazy. And I had thought about potentially splitting it up into like basically modules before that, but never kind of got around to it because I didn't think it was as clean. It wasn't as clean as I'd like to, but I at least had the template there from a previous attempt. So then I'm trying to remember when it was a few months ago, I went ahead and essentially re-architected the Server Connect program and basically broke it into modules essentially. So as a kind of a part of that, I essentially was just copying and pasting code around from the functions into other files. But the problem was remembering to import all of the files that these functions came from, because now they're of course not all residing in the same file, so you have to make sure that you call them correctly, otherwise the program won't be able to find them. So that's basically what happened here. The function was saying it wasn't defined, mainly because the function that I was calling it from, the file that it was in didn't actually include that function that it was looking for, so it of course couldn't find it. So that was just kind of a remnant of the transition to kind of a more modularized design. And basically that is kind of how I discover these bugs and come up with new features for this program, is I just happen to be using it, and then one day I either find a bug, or one day I discover a feature that I want added and I go ahead and add it. So I also realized that there was a uncommented try catch statement I had in there, which this actually didn't pose any issues. But it potentially could. Essentially, I guess I was doing it for debug purposes at one point. I had commented out a try catch around saving the connections to the file. I guess I was trying to look or do some kind of debugging there. So I re-added that try catch back in there just to, if the program does actually fail there for whatever reason, it won't crash and spit out an error message. It'll exit gracefully, which is what you generally want to have happen. So yeah, and it wasn't necessarily all that challenging to fix the error. Basically, the error was, so what happened was, when I was trying to add a brand new connection, as part of that process, the Server Connect program will try to dynamically pull the MAC address of the system to allow you to be able to use wake on LAN functionality that also exists. And as part of that, it tries to pull the MAC address through a function called get MAC address, and that get MAC address function was saying it wasn't defined because I moved things around and didn't import the file that get MAC address was from. So that was a very easy fix. So got those things fixed up and patched and pushed that to the old GitHub. And the cool thing, which is, I guess I'm pretty sure I touched on this already though, is the fact that you can just upgrade the Server Connect program from the program itself. So you can literally just run the -- upgrade, or I think, -- upgrade or -U, and it'll basically pull all the updates for you, which is super nice. But yeah, that's basically how I find all the bugs for that, because at least as far as I know, I'm the only person that uses it, which may or may not be true. I'm not actually that sure. But part of the reason I made the program in the first place was just for my own personal use. So if I am the only person that uses it, quite honestly, I don't care. And I'm still going to, of course, make patches for when I find issues. But if any of you out there happen to use this program and find issues, definitely let me know and I can get those patched. Or if you want to be a Giga Chad, I guess you could fork the project, make the patch yourself, and then submit a pull request. I guess you could do that too. But anyway, that was the bug fixing. And then moving on to some video game updates and touching into Ansible a little bit here. So first, I updated, so I have a script, which I believe I've talked about before, that handles installing all dependencies from GitHub. So currently it's just Raylib right now, and personally I'm not sure I ever see any additional dependencies being installed, but if I do want to install additional dependencies from GitHub, it's literally just adding, the owner of the repo and the repo name itself, and the script will do the rest. But one issue with this script was I was always downloading the latest release. And before this, I found a bug where it was actually downloading the latest commit, which was a problem. But downloading the latest release also could potentially be a problem, because if you're trying to develop stable software, you want to stick to known good releases. And the reason I say that is because depending on what a project decides to do, they could potentially change various functions in their API, or parameters that you need to pass in, or return values from an API. And if you don't methodically check and account for all this, it could either cause undefined behavior in your program, or it could cause your program just to not compile at all, which is basically what happened in my case, because when I was pulling the latest commit, it turned out that there was a function change in the Raylib library, in this developer build, if you will, from this latest commit, that broke stuff in my code and basically caused the program not to compile. So that was an issue. So I fixed that issue, and then I realized, if I'm always pulling the latest release, there will be a time where the latest release does basically this exact same thing and causes things to break. And of course, what I want to do is, the goal of this video game project is to eventually be completely open source and post it on my GitHub once I actually get it to a functional state. And the last thing I want is for it to be just pulling the latest version of, in this case, Raylib, and there's potentially changes in the API that goes on and causes the program not to build correctly, and then people get mad because they tried to build from source and it failed, and I'm like, what are you talking about? It works on my machine. And that would just obviously not be good. So that was kind of the main driving factor, was to basically ensure that the version being pulled by this script is a known version to be good, that actually compiles and is known to work with the game itself. So that was a big accomplishment, not really for like the actual functionality of the game, but just from like the administrative side of things. And then as far as the actual code itself, I actually went back and added native support for Clang. So this was kind of tangentially done. It wasn't necessarily intentional, but in case you didn't know, if you use G++, which is the compiler that I have my Makefile set up to use, or GCC for that matter, on a Mac, it is basically just a link to the Clang compiler, specifically the Apple Clang compiler. So at least that's the default behavior. Now you can, through like either the homebrew package manager, or I guess you could compile it yourself, create native G++ or GCC. But by default, if you try to invoke G++ behind the scenes, you're just calling Apple's Clang. So I rediscovered this issue in my project, and I say rediscovered because a while back, I had tried to compile with Clang on Linux in order to better use the address sanitizer to basically check for memory leaks and that kind of thing, because using an address sanitizer to check for memory leaks is a lot quicker than using something like Valgrind. Both get the job done, but just address sanitizers are a lot quicker. But it basically caused the compile to blow up because I was doing things that I guess the version of Clang that got installed didn't support. And I was like, okay, I'm going to do what any good developer will do and just quietly sweep this under the rug and pretend like it didn't happen. So this, of course, came back to bite me. Like, whenever you try to quietly sweep anything under the rug and pretend it doesn't happen, it always comes back to the surface. And, of course, this time it did, because I was playing around with a slightly older version of macOS and Xcode, specifically Big Sur and Xcode 12.5.1, I think. But anyway, it appears the feature set of Clang from Big Sur's version of Xcode, which happened to be Apple Clang version 12, isn't as updated as some of my other Macs with newer versions of Xcode that have Apple Clang 15 installed. So in case you're kind of wondering what the difference between Apple Clang versus regular Clang is, Apple Clang is essentially just a fork of the LLVM Clang project. So there are some minor differences, but it's basically just a fork, or kind of a branch off of the main Clang project. So because I ran into this issue on an older version of macOS trying to get it my code to build correctly, I decided it was probably about time that I actually fixed this issue rather than just letting it continue on. So that's what I did. I ended up getting that all fixed up and patched and got those updates made. So now it actually works and builds and compiles correctly. So the one thing that I think will be good about this is potentially this could potentially allow me to build on even older versions of macOS potentially. At one point, I even had it building, I think it was on Snow Leopard, I think was one of the oldest Mac OS versions I had it building on. But that was also, I think, back before I really started doing anything with Raylib 2, from what I recall, because there was a time where I even had the code not necessarily building, but running, I think all the way back on like Windows 98, I think. I think I had some issues on Windows 95, but like we had some compatibility going way back. But of course, then switched over to 64-bit and, added Raylib and some other dependencies and whatnot. And the compatibility kind of dropped off a little bit. But because I could actually, in theory, natively compile on hopefully older versions, fixing this Clang issue, I am optimistic, and maybe that's something I'll try here in like the coming weeks if I remember, to see if I can get this building on some older versions of macOS. Because at the end of the day, I have the make file, so I can literally just run it, and as long as make's installed and has the build tools installed and whatnot, I, in theory, could get it to compile, but I guess that's something I'll have to play around with. Now getting into the Ansible segment. So the first Ansible thing I wanted to touch on was when it comes to the video game. So a while back, I had created 3 Ansible playbooks, and in all honesty, they're all very redundant. The first one was to build the video game on Windows, one to build on Linux, and one to build on Mac OS. Now, the difference for the Windows and the Linux and Mac OS one is quite obvious, because if you've used Ansible before, Windows is its kind of own world and doesn't use the standard function module names, if you will. So, for instance, rather than saying like file or shell or unarchive or things like that for that you would use on like Linux or Mac OS, on Windows, you basically prepend everything with win underscore. So it's like win underscore file, win underscore shell, and so on. And it's from a different community package. So there's some differences, so it kind of makes sense that you have to kind of split them up. In theory, you could do some tagging or do some conditionals. So like when the OS is Windows, then you do this. Otherwise, skip it. That kind of thing. So there are ways that you could put it all in the same playbook. But for the sake of, I guess, cleanliness, if you will, I kind of divided them up. But I was going back through the playbooks, and I looked at the Linux and Mac OS playbook, and I kid you not, they were basically verbatim the same, aside from Linux and Mac OS specifics. So, for instance, the Ansible task to actually build the game itself, it's on Linux, it was like create Linux package, and on the Mac OS one, it was like create Mac OS DMG, and then it had behind the -J, it was like nproc on Linux for basically get the number of processors, and then on Mac OS, it was the Mac OS version of that. But aside from that, it was basically the exact same. And recently, I had updated my make file to add a new rule called make package, which would essentially detect which operating system you're running and choose the correct package thing to make, right? So if you're on Windows, it'll create the Windows executable, and it'll package all the dependencies and the resources and zip it all up into a .zip file. If you're on Linux, it'll do the same thing, but for Linux, and create a tar.gz. And if you're on Mac OS, it'll create the Mac OS app with all the dependencies and everything, and then put that into a DMG file. So all that's good. So now I can essentially completely remove that difference between the two versus the create Linux package and create macOS DMG. And then I can just do something very simple, like pass in an extra variable as a command line argument to essentially specify how many threads to run, or in this case, what the argument to give the command line for the -j is. So in instance for Linux, it's that nproc thing. And then Mac OS, it's this kind of weird string, which I don't even remember off the top of my head. And quite honestly, I don't even use it because I actually have an alias in my bash profile or bash RC to basically put it to something else that's a lot easier to remember. But for the sake of the playbook, I actually did use the whole thing, so it would actually work on other Macs that aren't my own. But with that out of the way, at that point, these two playbooks are identical. So I was like, all right, so we are just going to scrap these two playbooks and just make it a single playbook and then just pass in the appropriate command line arguments when we run the playbook to make it for Mac OS or for Linux. And that's what I ended up doing. And quite honestly, I think this is a much better solution because it cleans everything up and just removes basically all the duplicate code, which is fantastic to see. And the other thing I kind of did, which we're going to get to also in the Ansible updates, is I updated the how I was calling the different functions. I don't think functions is the right word, but the different like modules in Ansible. So like I mentioned, the file, the shell, that kind of a thing. So in Ansible, generally, if you look at the I'm trying to think of if you look at people's like GitHubs or whatever of Ansible playbooks, they'll generally have like the full name of what the thing's actually called. So the actual, I guess the terminology for that is I'm trying to actually find this in my commit history, which is why I'm stalling here, which I can't seem to find at the moment. But basically I think it's like the fully qualified something name, something or other. And basically the point of it is to basically make it more clear what you're actually calling and remove the potential of you thinking you're calling one thing, but you're actually calling something different. So that's kind of the point of it. So I basically switched all over to that, and not necessarily for, well, I guess there was some for the actual playbook itself. Okay, here it is. Ansible fully qualified collection names. That's what I was looking for. So yeah, the fully qualified collection name is essentially the full name for it. So let me actually pull up one of these playbooks here. So for instance, rather than just calling stat, it would be ansible.builtin.stat. So if you look at someone's playbook on GitHub, it will generally look like that. If you look up the Ansible examples, they'll be essentially formatted like that. And that's basically what Ansible recommends you use. But one thing that I kind of had a bad habit of was if I didn't offhand know what the module name was, I would essentially just run a shell command and just do it through the shell. And don't get me wrong, that worked, but it wasn't exactly the Ansible way. So for instance, in the Ansible playbooks for the video game, the Pokemon game I'm working on, part of the process of the build is I compress all of the requisite files that are needed for the build, put them into a zip file, copy them over to the remote machine, unzip them, and then cd into that directory, and then build the code. But for the unzipping portion, I was essentially just doing that through a shell command. When, of course, in Ansible, there is an actual dedicated module thing for that. In the case for Unix systems, it's unarchive, so the ansible.builtin.unarchive. And I wasn't using that. I was just doing a shell command. So I switched that over and actually did things the Ansible way, if you will, rather than just doing things through the shell commands. Now, this goes even further because in addition to updating the Ansible playbooks for my video game, I also updated the Ansible playbooks or specifically the one Ansible playbook for my update script. So I have an Ansible playbook that essentially updates all of my servers in my home lab. And it will update everything from it'll go through, update Pi-hole, it'll update Docker containers, it'll update Bitwarden, it will update my Debian servers, my Red Hat servers, my Arch servers. And when I say, I'm assuming basically lumping these into families. So when I say my Debian servers, I'm talking about the Debian-based distros I have. So like Ubuntu, Debian, actual Debian, Kali Linux, that kind of a thing. Red Hat would be things like Red Hat or Rocky Linux, Alma Linux, Fedora, that kind of a thing. And then Arch Linux, Manjaro, that kind of a thing. Like basically the families of distributions. So I updated that to add tags to it. So one cool thing that Ansible allows you to do is specify tags. So you can essentially, if you only want to run a certain portion of the playbook or only a few select plays in the playbook, what you can do is you can add tags, and then when you run the playbook, you can specify which tags you want to run, and only plays or tasks with those tags will actually end up running. So the cool thing about this is sometimes when I only wanted to update, say, my Red Hat servers because I just recently added a new one, I don't necessarily want to run through the entire update playbook. I just want to update the Red Hat servers, right? So what adding these tags allow me to do is to specify, like, hey, Ansible, only run the update portion for the Red Hat servers, and it'll skip everything else, do the Red Hat update, and then be done. So it goes a lot quicker. So the other thing the reason I like this is when I was developing, and well, I guess it's still technically considered in development because over time I've added additional things. I'll have these individual playbooks, which are basically just for the testing portion of this broader playbook. So for instance, when I was working on adding functionality to update my Docker containers, for instance, I wrote a separate Ansible playbook to basically test out that portion of the playbook before I added it into my larger playbook. But now in this case, by actually using tags and using them effectively, I don't necessarily have to develop like a secondary playbook to do the testing and then include it in and then have to run the entire playbook. I can essentially just write the new task or play or whatever I want to add a tag to it, and then I can just run the playbook specifying that tag, and only that new portion that I have been adding will actually run, which is definitely something that's really cool to see. And now, if I wanted to say just update the Docker containers, I can literally run my normal update playbook and just specify Docker, and only the Docker containers will get updated, which is definitely really cool to see. And the other thing I also did was similar to the Pokemon games playbooks, as I added those fully qualified collection names, right? So I did that, and also actually did things more the Ansible way, since there were a couple instances in that playbook too where I was just kind of doing some shell commands rather than actually doing things the Ansible way. So those were basically the main updates I did. But since we're on the topic of Ansible, I just wanted to go over again why Ansible is so amazing. And I know I've mentioned it before, and I'm going to bring it up again, and this isn't, of course, the first time I brought it up, and this definitely won't be the last time I brought it up. But one of the big benefits to Ansible, in addition to it just being straight up awesome, is the fact that you only need Ansible installed on the machine that you're driving the playbook from. And what I mean by this is if you, say, have your laptop that you are essentially managing your home lab from, you only need to have Ansible installed on your laptop. All of your servers, all of your virtual machines, you don't need to have Ansible installed on them. You only need it installed on your laptop. And this is kind of in contrast to some of the other automation tools that are used in the industry, like Puppet, for example, where if you're using Puppet, you have to have what's called agents installed on all the various machines that you want to control, if you will, in order for them to actually work. But with Ansible, it just uses SSH. So as long as you have your SSH key shared with the host that you're trying to connect to, you're basically golden, which is fantastic. It makes it super easy to get up and running. Now, while personally I mostly use Ansible for managing my various Linux systems because my home lab is virtually all Linux aside from a couple like test machines and virtual machines for like Windows and Mac OS and whatnot, the majority of my systems that I use Ansible for is Linux, but you also can use Ansible for administrating Mac OS and for Windows as well. And there is like an entire collection of different like modules that you can use specifically for Windows, as I kind of touched on earlier in the episode. But for me personally, I also use Ansible, as I've just mentioned, for deploying and building code on other operating systems. So, for instance, if I'm developing on a Linux machine, I can run Ansible playbook, like my playbooks I literally just touched on, to build my code on Mac OS and Windows systems and get builds for those without having to manually log into a Windows VM or manually log into a Windows system and pull down the code changes, build it and whatnot. I can just run an Ansible playbook and it does it all for me. So absolutely fantastic. And the other thing about Ansible too is you don't necessarily have to be a programmer in order to make it useful and be good with it, because while some people call it like coding or writing code, Ansible uses the YAML format for its playbooks, which if you compare it to like actual programming languages like Rust or Java, YAML is pretty darn human readable. So for instance, going through one of my playbooks here, so this is the build playbook for Unix systems. So you have first name, and this can be whatever you want, and then ansible.builtin.stat, path, the destination zip file, and register zip. And then later on in the playbook, we check if that zip exists by doing when stat.zip exists. And then if it does, we have file. So talking about the file, what file is it? It's that zip file. And what state do we want it to be in? Absent. So of course, how I said that was kind of robotic and not necessarily human readable, but if you actually look at the YAML, which if you haven't looked at Ansible YAML files, I definitely encourage you to look at some, but it's fairly straightforward when you look at it, seeing what it's actually going to be doing step by step. So it's not necessarily overly complex, like you have to learn this crazy syntax of a programming language and figure out what all the different functions do and what all the different built-in data types are and different built-in algorithms and all, and the various syntax for a programming language. It's fairly, of course, this is coming from my biased opinion of having used Ansible for a few years now. But I talk about playbooks, and if you're unfamiliar with what that terminology is, essentially what playbooks are essentially comprising of different tasks or plays, which are just a set of routines that should be executed on the remote machine. So essentially a playbook you can kind of think as your YAML file, and then within your YAML file you have what's called your plays, which are the broader collection of multiple tasks. So for instance, on my update script that I've talked about before, if I go ahead and quickly pull that up, it has multiple plays within the same playbook. So for instance, I have a play to essentially update DNS servers, and then within that play, there's a task which updates Pi-hole. For instance, I have a broader task that updates the servers in general, and then within that play, there are smaller tasks like upgrading the Debian servers, upgrading the Red Hat servers, and so on. So it's just, and then there's another play later on, which is what sends the update to my phone to basically tell me that the update's completed. So essentially, kind of recapping here, playbooks are a collection of plays, which are a collection of tasks, which tasks are the individual actions or routines that should be done on the server. So a task would be something like copying a file to the server, or unzipping a file to the server, or building source code, like running make or something like that. Applying like an update, doing an app update or something like that. So those are the individual tasks, which then comprise the plays, which then comprise the playbook. So the other cool thing is how seamlessly you can integrate Ansible into your CI/CD pipelines, or your continuous integration and continuous development pipelines. So, for instance, a really easy example that I can think of is if you imagine, so right now I have a CI/CD pipeline that I have set up where whenever I push code changes for the video game I'm working on, it will build my Doxygen documentation, create a Docker file with that documentation, and then push that Docker file to my Docker host and basically update it so I have a live, always updated copy of my documentation that I can access through my web browser. So that's, of course, a fairly small scale example, but you can imagine a larger scale example if you were, say, deploying something like microservices, for instance, and you had to deploy these Docker containers to a lot of different hosts in order to update them. You could essentially use Ansible. So once your Docker container has been created, you can essentially use Ansible to go out to all of these hosts at the same time and basically tell them to go ahead and pull the latest changes from the Docker registry that you just pushed to through your CI/CD pipeline. So it's super powerful. And the other thing with Ansible too is if you're using it with, say, like Linux or Mac OS, it's honestly fairly snappy with how quickly it can perform these tasks. And the back end of Ansible, it's just using SSH. If you're using Windows, it can be kind of hit or miss. You can use SSH for Windows, but you have to kind of, at least how it used to be, I'm not sure if Windows has changed this in the past couple years, but how it used to be is you kind of had to jump through some hoops to get OpenSSH working on Windows. But you could also do another thing called, I think it was like WinRM was the other way that you can get Ansible working on Windows. But either way, I've tried both of them, and to be honest, neither of them are all that fast, although from some of the reading that I've done online about it, it seems to be kind of more of a limitation with the backend, specifically with WinRM. The WinRM, I think, Python package that gets used, it's not necessarily an Ansible thing per se, but regardless, if you're using things like with Linux, which generally I think Ansible is generally used for, and especially in this example of like deploying Docker containers, it'll be honestly very quick to reach out to all those hosts, have them execute the play to pull down the latest Docker container and be up and running. So can very easily seamlessly integrate Ansible into your CI/CD pipelines. And the other thing that's also fantastic with Ansible is how easy and trivial it makes configuration of your systems. So for instance, if you, and quite honestly, this is something that I would recommend, is when you're first starting out configuring, if you want to get into, especially if you want to get into Ansible and home labbing, one thing I would recommend is rather than manually logging into the system to install and configure whatever you need to do it through Ansible. Now, of course, when you're first setting it up for the very, very first time, it can be helpful to kind of go step by step on the machine itself to kind of get an understanding of what you need to do. But the problem with that is it's not repeatable and it takes time, right? So even if, like, one thing that I've done is create wikis for to remind myself how to do things, because I can't tell you how many times I've set something up and then I'll have to redo that thing like a few months later, completely forgot how it's done, and have to go redo the research I already did to figure out how to do it. So that was kind of the nice thing about the wiki, that I could just kind of go back to it and, redo the steps that I already did. All that knowledge is right there. But Ansible essentially puts that on even easier. So if that's easy mode, it basically, Ansible just puts it on like autoplay, because what you can do is you can just rerun the playbook and you're back to where you were. So kind of getting back to the configuration here, if you first kind of go through the step-by-step process of getting whatever service you want installed and configured, then what I'd recommend doing is, now that you know how it's done, essentially revert it back to what it was. If you're using like a hypervisor, you can create a snapshot before you actually do all that configuration, so you can easily roll back to before any of the configuration was done. Then you can go ahead and write your Ansible playbook that will basically do all those steps you just did, but in an Ansible playbook, and then you can run that playbook, and then assuming you did everything right, your server will be configured just like you had it before. And if it's not, because you created the snapshot, you can just roll back, tweak the playbook, run it again, and just keep going until you get it the way you like. And then you can nuke that server as many times as you want, rerun the Ansible playbook, and it'll be back in action. And the reason why this is so fantastic is it makes the potential of, say, some kind of data corruption or whatever a lot less impactful, because if you can just, essentially wipe the system, reinstall your operating system, run your Ansible playbook, and you're good to go, that removes so much of the headache and overhead of trying to reinstall these services. Because the other thing too is, once you get it configured a certain way that you like, it's just ready to go. So for instance, if you have a fleet of servers in production that need to be configured a certain way, if you have an Ansible playbook set up to configure that, all you have to do is bring the new server online, point your Ansible playbook to run on that server, and then bingo bango, it's ready to go and be deployed into your fleet with basically no work by you. So it's an absolutely fantastic automation tool, and is a fantastic way to get your new servers up and running very quickly and in a very repeatable manner. And I've even kind of dipped my toe into the water. I haven't gone like full blown into that per se, but one of the use cases I have is I have 3 different template VMs on my hypervisor right now. One for Debian, or one for Ubuntu Linux, one for Red Hat, and one for Arch. And I wrote an Ansible playbook which will essentially configure this template to essentially be a brand new machine. And what I mean by that is, what I can do is I can clone the virtual machine template that I want. So for instance, if I want a new Ubuntu VM, what I can do is I can clone that instance, point my Ansible playbook to it, essentially tell it, hey, I'm creating a new Ubuntu machine. This is the IP address I want it to be. This is the new user. And it'll essentially go through and configure that system, remove the old SSH keys, essentially generate new ones to basically create it as a brand new virtual machine, apply any updates that are needed and anything like that, which quite honestly was kind of annoying to have to go through and do all manually. So that's part of the reason why I wrote an Ansible playbook for it. But I haven't necessarily had a ton of instances recently where I've been playing around with new systems or new tools in my home lab per se, in order to really make an Ansible playbook to do it all for me. But that is definitely something I'm going to be keeping an eye on. And you can bet if I get around to, say, installing a new service and do it through Ansible, you will no doubt be hearing about it. So that was kind of another rant, I guess you could say, of me praising Ansible and why it's so good. And in case you're wondering, no, I'm not sponsored by Ansible at all. I just use the tool and think it's pretty freaking fantastic, and makes my life so much easier and makes the operation of my home lab quite honestly a breeze, because I will say, when I first started home labbing, I thought it was like so cool, having to manually log into these servers and like run updates and stuff. And then after you have to do the same thing over and over and over again on multiple machines just to keep them updated, gets old pretty quick. But Ansible, I literally have it set up where I can just log into my jump box, run one command, exit, and then in a matter of minutes, I'll get a notification on my phone saying, "Hey, your update completed." Occasionally, I'll get a notification saying that my home lab's down, because either the VPN VM restarted or something like that. But it is cool that I can literally just log into a jump box, run a single command, exit, and then go about my day, and then in a matter of minutes just get an update on my phone saying that you're good to go. So that's Ansible. If you haven't used Ansible, I highly recommend checking it out, especially if you have a home lab. But before we leave for today, we should get back to our trivia question. So this week's trivia question is about the IEEE, which is well known for standardizing things like the IEEE 802.3, which is a collection of standards produced to define the physical layer and data link layer of wired Ethernet. But what does IEEE stand for? So again, what does IEEE stand for, or IEEE? If you said Institute of Electrical and Electronics Engineers, I can't talk there. Institute of Electrical and Electronics Engineers, congratulations, you got this week's trivia question correct. So congratulations if you did. And if you enjoyed this episode, I ask that you leave it a rating, review, subscribe if you haven't done so already, and be sure to share this around, especially to anyone that might need to learn a thing or two about Ansible to make their life easier. If you have any questions about this episode, or if you have any comments or questions for future episodes, you can either leave a comment down below if you're on YouTube, or shoot me an email at contact@darkassassinsinc.com. The link for that is down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.